So if we want now to prove Parseval's theorem, it's going to be one of these proofs by computation. So let's run through this proof. So to prove this, the idea is we're going to begin, right, with the inner product phi and psi, right? And what we're shooting for, right, I'm not going to assume anything, no circular arguments here. Just want to remind ourselves we're hoping to show, just like the line above, I need to massage this thing into the form V star n Wn. But to prove that, I have to go through a series of manipulations that I know are independently true. Now, the basic idea is then to massage this to get into some form where I've got V's and W's. Clearly the way to go will be to substitute in these expansions, right, which I'm presuming, that's the if part of my theorem, that I have these expansions. I can insert these expansions into my Hermitian inner product and then grind through and calculate. Now, I could do both at once, but let's try to keep our algebra as simple as possible. Let's go one at a time, simplifying before we move on to the next expression. So if we are to do that then, let's substitute in the expression for phi. So for phi, you see, phi is this sum. So I will have sum on n, Vn, capital phi sub n, my nth energy state. Inner product then with psi, bracket with psi. Now, notice that I've substituted in a sum, but there are no other indices n that I might get confused with, so I can just leave my temporary summation variable as n. Now, next step. Once again, remember, the Hermitian inner product is a bilinear form. The summation and pulling out constants aspects work on either side of the Hermitian inner product. So in this one as well, I can actually pull out the sum on n. I can pull out the coefficients v sub n, and that leaves me with this inner product phi sub n with psi. Now, if you're following my algebra carefully, you will notice I've left something out of this expression. So this is the last time I'm going to write down our crotch. But just as a quick reminder, if we were to think about this in the traditional representation, my inner product is integral dx. The bra part has to have a complex conjugation applied to it because it's a Hermitian inner product. And then that multiplies, of course, my wave function psi. This is my psi of x. And now, looking this over, I'll make a final bubble here, right? You'll notice that when the Vn gets pulled out of the expression, it has to first have the star applied to it. So it ends up with the star coming out. And that's a general feature of these Hermitian inner products. Always remember that the first part, the bra side, is always associated with complex conjugation when we move things around and pull things out. Very good. So we can see, though, that we can certainly pull out the sum and my coefficient with the star. Now, the next step here, I think, should be fairly quick because we have this interesting feature. I'm taking an inner product of one of my pure states with my quantum state psi. But this is exactly what we had proved earlier, that inner product always just plucks off the corresponding coefficient. So this is actually just Wn, and then voila, we're pretty happy, right? Look, we've got Vn star times Wn. It's just an inner product, sum on the same ends, but it's Hermitian inner product with the star. It's just what we had hoped to prove. So Parseval's theorem then holds, which definitely makes us very happy because we can now calculate inner products in all kinds of different representations. The other beautiful thing about this is then my probabilities automatically come out normalized. So that's about what I think we would want to say at this point, just generic features that we expect when working in a bound state situation where we have discrete energies making up our energy representation. We are now ready to begin to consider specific examples with specific potentials.